This lesson is going to be looking at squares and square roots. So a square is a certain type of exponent where the exponent is the number 2. From the diagram you can see the large number is the base and the exponent is the small number. The exponent tells you how many times to multiply the base by itself. So if we're looking at reading this, that would say 5 to the second power, or because the exponent is a 2, you could say it as 5 squared. So basically it means to multiply 5 by itself 2 times. So 5 times 5 gives you 25. The list that you see on the bottom of the screen in blue is going to be a very important list for you. Those are the first 20 perfect squares. Like 1 squared is 1 because 1 times 1 is 1. 2 squared is 4 because 2 times 2, or 2 squared is 4. 3 squared is 9, 4 squared is 16, 5 squared is 25, etc. That way you have a list of the first 20 so you don't have to do the multiplication over and over and over again, because you probably know the first couple, but then once you get in the numbers above 10, 11, 12, and so on, then they're probably harder for you to remember off the top of your head without doing the actual multiplication. So what are squares useful for? Squares are useful when you're talking about area. Area is always measured in units squared, and here's why. It's always measured in units squared because if you're looking at a square, the formula is area equals length times width. Or, because we know about the square, all 4 sides are the same. So we know that the length and the width are the same. So we could say that it's the side to the second power. Because if I was looking at this, I would have area being 7 times 7, because it's length times width. Length is 7, the width is 7. But an easier way of writing it would be 7 to the second power. 7 times 7, or 7 squared, would give me an answer of 49. And then my units are centimeters. And then again, my units are always squared, so I have 49 centimeters squared. Let's think about this backwards. Let's say now we're looking at a square and we know the area. We know the area is 81 square centimeters. We want to figure out what is the length of each side. So just a minute ago, we took the length and the width and we multiplied it together. And remember, in a square, the length and the width are the same. So we have to basically think what number times itself is going to give you 81. Well, we know that 9 times 9 is 81. So my length of each side of my square should be 9 centimeters. An easier way of doing that problem may have been doing something called the square root. The square root gives you a diagram there. The number, sometimes you'll see a number outside the little symbol, the radical symbol. That is called the index. If it's a square root, we assume that the number is a 2 and we don't necessarily write it. The little square root symbol is called a radical, and the number underneath it, in this case is 16, is called the radicand. How you would read that would be the square root of 16. Basically, that was like the problem we just did where we found the side length. It's asking you what number times itself gives you 16. So we know what number times itself, 4 times 4 gives me 16. So the square root of 16 is 4. This here in blue is something very important to recognize. It says taking the square root of a number is the opposite of squaring a number. So when you have something times itself, the opposite is figuring out what times itself gives you that number. So again, if we take a look at a problem just like the previous one, it says the square has an area of 144 square centimeters. What is its length? So we need the number times itself that gives me 144, right? So essentially that's the same thing as saying we're looking for the square root of 144. So we need what times what gives me 144. And remember, it has to be the same number. So we know that 12 times 12, or 12 squared, is 144. So that means the length of each side is 12 centimeters. Last thing I want to take a look at is if we have an equation that has a square in it. In order to find out what x equals, you have to take the square root of each side. Notice it says unsquare the equation by taking the square root. So I want to take the square root of x squared, and I want to take the square root of 64. So what happens here is that the square root and the square, they're opposites, so they cancel each other out. So all we're left there is with x. And then the square root of 64. That's asking what number times itself is going to give me 64. So I know that 8 times 8 is 64, so the square root of 64 is 8. Now these are special types of equations because 8 is not the only number that I can multiply by itself to give me 64. Because I know that 8 times 8 is 64, but there are also another set of numbers that I can multiply by each other that would give me 64 as well. And that we should think back to the rules of integers. I know that negative 8 times negative 8 should also give me positive 64. So that means that my answer in terms of this equation is both positive and negative 8. The only time that you need to include the positive and the negative in your answer for a square root would be if you are solving an equation, because that is asking you what are all the values that x could possibly be. So normally you would just tell me, if I just asked you the square root of 64, you would tell me that it is positive 8.